Well, good afternoon, good evening, good morning, whenever you watch this. As we delve into our solving multi-step equations, here are our steps, and we're missing step 3. We've talked about the distributive property. We've talked about combining like terms. We have undone addition and subtraction, and we have undone multiplication and division. But what is step 3, the missing link? And that's what we're talking about today. It is collecting variables on one side of the equal sign. What's that mean? Collecting variables on one side of the equal sign? Well, it looks like this. Sometimes you will see problems like this right here. 3x plus 2 equals 7x. If you look at that, you'll see, well, whoa, there's a variable here. The x is on this side of the equal sign here. And lo and behold, there's another x over here on that side of the equal sign. We need to get those x's, those variables, on the same side of the equal sign. All right. So really, to do that, we go back to the things we already know, step 4 and 5. We can undo addition or subtraction the same way as when we're solving equations. We can subtract 3x from both sides of the equal sign to get rid of the x right here because it's the opposite. Or we have a choice sometimes. We could subtract 7x from this side of the equal sign. Now, I would suggest strongly that when you have your choice that you do, this will work. You could do it this way. But if you were to subtract 7x from both sides, you would get 3x minus 7x is negative 4x plus 2. Now, the equal sign needs to slide down, and 7x minus 7x is 0. That's going to add an extra step. I have seen too many times in the last many years of students do it this way, and what they do is they move the equal sign. So if you have a simple equation to move, like only two variables, don't move the one that's by itself. You're much better off moving the variable that's has other terms next to it. So this is what we're going to do. This is how it works. We're going to subtract 3x from both sides, and we can do that. We can do that. Now, some elementary teacher somewhere, I think, or maybe it's one of our 7th grade teachers, is teaching kids to always put the equal signs in every step and even draw a line down them when they're through to keep things keep the equal sign right there. That's a good idea. I like that. But if we do, so let's go ahead. We subtract 3x from both sides. 3x minus 3x is nothing. The 2 slides down. We've done nothing to it. The equal signs stay in line. 7x minus 3x is 4x. And now we can solve. You know how to solve this. We have done that. That is steps 4 and 5. I'm not going to go into that. You know how to do that. We're talking today about getting the variables on the same side of the equal sign. It can get a little bit more complex. Here, let's do another one here. We have 15 minus 2x equals negative 7x. So what we want to do is we want to move this. We don't want to touch this 7x. Leave it over there. We'll just collect this x, stick it over there by adding 2x to both sides. So when I do that, I'll add 2x to this side. I will add 2x to that side. I can do that because the equal sign's in the middle. It balances. I then end up with negative 2x plus 2x is gone. The 15, though, still comes down here. Equal signs slide down in order, and we have negative 7 plus 2x is 5x. The simplest way to collect the variables on one side of the equal sign. But of course, it can't always be that easy. Here it is. Now we have to go back to our steps. This is why the collecting variables is third. If you have distributive property or terms that need to be combined, you want to do that first. Then you move the variables. So that's why it's step number 3. So first of all, we need to do the distributive property. We did that in a previous video, in a previous lesson. You know what that would be. In this particular case, if I use a distributive property, I get to that. All right, if you forget that, you can review this and see how we got there. So now we've got a sticky situation because we have a negative 2x here and a negative 3x there. And there's numbers also on both sides. So actually, you know what? You have a choice. You can do either one. You can move this to negative 2x, or you can move that negative 3x. It doesn't really matter which way you go. So let's do the first one. I'll show you, let's add 2x to both sides. If I were to add 2x to both sides, negative 2x plus 2x, it goes away. The 10 would come down here. Equal sign stays. The 12 slides down here. But now this negative 3x plus 2x becomes a negative x. This is that simple. Okay, it looks, but you could, so when you do that, the number here, I believe, will be negative 2. You would then subtract 2 and get negative x and negative 2. So that's one way it will work. You will get negative 2 as your answer by subtracting 2x from both sides. Or another way, which is perfectly acceptable, and if you can think ahead, it might even be easier for some, is you could add 3x to both sides. You will get the same answer. If I add 3x to both sides of my equal sign, negative 2x plus 3x is x. Okay. The 10, I'm not changing that. It comes straight down again. Plug in my equal signs are all in a line. I got 4 of them right now. The 12 slides down. We've not done that. But look here. The minus 3x plus 3x is 0. It's gone. So now we have a simple equation. X plus 10 equals 12, which also equals 2. So no matter which way you did that, following your steps, you will get the same answer. Variables on both sides of the equal sign. And our last, I'm going to skip that and go right to my favorite one. So we do this. I wish we were in the classroom, because in the classroom, I've spent 15 minutes doing these and everybody is perfect at it. You're thinking they're really good. And then I give a problem like this. And it's one of my favorite days in the classroom, because all of a sudden the room gets quiet because the minds are really working. So let's go ahead and do this one. We have the distributive property, so we'll take care of that. And you can do that really easily. 5m minus 50. And then you're following all the rules. I have variables on both sides. So kids, go ahead and, well, I'll subtract 5m from both sides. And you do that. And then what you end up with is you see 5m minus 5m is 0. 5m minus 5m is 0. Goes into nothing there. But and then negative 50 comes down here. Okay, the negative 50 comes down there. I actually should subtract that negative 50 there. That makes more sense. So you end up with 0 equals negative 50. Does 0 equal negative 50? No. So kids go back and keep trying to find out where they made a mistake. Where they made a mistake. They didn't make a mistake. Trust your steps. You're right. 0 does not equal negative 50. You can even tell that right up here in this step here. 5 times a number equals 5 times the same number minus 50. That just can't happen. And every now and then we will get an answer that is no solution. That's okay. It happens. If you trust your steps and you get to a point where you get different numbers equaling each other, you know that's not true. It's no solution. And the flip side of that is a problem like this. I'll do the distributive property. I end up with 4 minus 4p equals minus 4p plus 4. I add 4p to both sides because I'm moving my variables to the same side. I get 4 equals 4. 4 equals 4? Yes, it does. This means if you go trust your steps and check them, if you end up with 2 numbers equaling each other or 2 variables equaling each other, you have an infinite solution. Any series of numbers will work for that. Okay, is this the last slide? I believe it is. We'll skip that. So that is your nutshell variables. Collecting variables on both sides of the equal sign. The ID card for this today is the 4 of spades. The 4 of spades. Thank you, and our equation solving is coming along very, very nicely.